Okay, well, we can start. And yeah, like Mel said, we're so happy to be able to do this, and it's just such a big thanks to all the people who've been helping us, and to Merle as well, because you've got such a brilliant drive and enthusiasm for research. It's really inspiring, and we're so happy to be able to present everyone this day today. So what I want to do in this first kind of opening talk is actually to introduce the world of touch, because this is, hopefully we want this to be open to everyone. So this is accessible to researchers, but also to the general public. And we want everyone to be able to understand how important we think the sense of touch is, and also how important the impact of not having touch can be as well. And so what I want to do in my talk today is to cover some of these aspects, talking about the basic mechanisms of human touch, and also how touch habits have changed in this COVID pandemic, where we are told not to touch people. And so I won't go into any depth of studies done on this. This is for the rest of the day, but I just want to have this as an opening presentation to kind of open the whole day and introduce the world of touch, which I'm very enthusiastic about. So my title is Perspectives on the Function of Human Touch and Changes to Touch Habits During the COVID Pandemic. During this pandemic, we are always told to stay safe, but to stay safe, you have to keep your distance. So
Rochelle, I think your mic somehow got misplaced, but you're now a little bit quieter than you were before.
Okay. Is it better if I'm a bit closer?
It's still a little bit quiet, but
Okay. I will see if I can turn up the microphone.
It just got muffled all of a sudden. It was perfectly clear before.
That's
much. Well, I think there was a cable. Yep, now it's better.
Okay, good. New computer issues. In the COVID pandemic, we have been told to stay safe, to stay healthy, to stay alive. You have to keep your distance from people. And so this is not great for the world of touch. And so basically it's kind of the COVID pandemic versus touch here. And so it has changed the way we interact with our environment, and it also has changed the way we interact with each other. And I want to talk about these two themes in my talk today. And how I want to kind of devise it in two is that the way we interact with our environment can be known as discriminative touch, and the way we act with each other is often known as affective touch. And one thing I like to bring out is that touch is a language, and it's a language that we understand instinctively. I often say this. I often say it in my talks. I often say it to my lab group, things like that. But I find it so true. You don't need to learn how to touch. Touch is the first system that develops. We have our skin that coats us in the womb. It's the first system to develop when we're young. And we know how to touch. We just do it. It's instinctive. So it's obvious that the way we interact with our environment has changed. We're told that things are dirty, we can't touch them. And the way we interact with each other as well has changed, because we're not allowed to touch each other in case we transmit the virus. And so this has had a massive impact in our lives. So to talk about these two types of touch, we typically think of discriminative touch as when you touch a material, an object. For example, when you pick up a pen to write. For example, when you touch a door handle, which now you're not allowed to do anymore. And so all these kind of different things, we typically think of discriminative touch. And this is what we normally use our hands with. Although we do have discriminative touch across our whole bodies, because discriminative touch is the what, the when, the how long in touch. And so it's, when did it happen? It happened right now. What did it feel like? This is the conscious aspect of touch. However, touch can be followed up by what we call an affective side. And so you can see here in the pictures, it's somebody hugging. It feels good, or touching a child, or giving someone kind of a pat on the back. This is more the positive aspects of touch, and so pleasantness, and also you can have negative aspects of touch as well. So example, touch can be unpleasant. It's not so good, it doesn't feel so good. However, it's important to feel both the positive and the negative aspects of touch, but this is more the emotional side of touch. And so we have this all the time. Touch is nearly always discriminative and affective, because when you touch something, it's conscious, you feel it. That's the discrimination in touch. But then afterwards, you will always have some kind of affective evaluation, an emotional feeling about it. Did you like it? Was it pleasant? Was it unpleasant? And so you have to take all of this on board when you think about touch. So a little bit of the skin, where it all happens. And so this is a beautiful drawing that was commissioned by, does the sound look good?
I think there's a cable that's a little bit wobbly or something.
I have no idea what's going on. Is this okay now?
Yeah.
Okay. I shall move the cable back. This is still good? Hey, live talks. Thank you, Mel. And so this is from a paper in Neuron from Francis McGlone and Johan Vestberg and Håkan Olesen in 2014. And it gives an excellent overview of the skin. And basically it shows the complexity of the skin. You have many, many different types of receptor for touch. For example, you can see on the left-hand side, you have the hairy skin, and the hairy skin is basically the skin that covers the majority of your body. Whether you can actually see the hairs or not, it's still classed as hairy skin. And on the right side, you have what we know as glabrous skin, for example, the palm of your hand, where the hairs aren't present. And so in these two different types of skin, you have mechanoreceptors, which will sense pressure, vibration, touch, things like this. And these will encode the messages and send them to your brain to be interpreted as touch. You have many, many different types of receptors in both the hairy skin and the glabrous skin. However, the density is much higher in the glabrous skin. Typically, the conscious discriminative side of touch is signaled by what we call A-beta afferents. And these are afferents which have certain receptors, end organs at the very end of them. And they send the message very, very quickly to the brain. And that's why we know it's the conscious aspect of touch. However, you do also have a different side to touch, which we think is more signaled by something called a C-tactile afferent, and that's the emotional affective side. Although it's true that the A-betas can still signal kind of the pleasantness of touch, but it's not in the same way the C-tactiles. And so C-tactile afferents have gained a lot of press in the news recently because they've been implicated in the pleasantness of touch and also in the importance of social touch, which is obviously what we're lacking at the moment. So I want to go on today to talk about the research on C-tactile afferents in particular and their importance in social touch. So for discriminative touch, you do use your hands a lot. It's very well known that to actually sense things, to explore your world, you go out, the sound. I haven't changed anything. Very well done. Is it a problem that you can't hear me? Or is it quiet?
It's just very quiet, but it's fine. I can make out. If everybody just turns the volume up, they'll hear you perfectly.
Okay, sorry about this.
Don't worry.
Yeah, my everything's at full here, so okay. So for discriminative touch, you tend to use your hands for this, and this is because you have about 17,000 mechanoreceptors in your hand, which is a lot of touch receptors to convey this information. And this is why you are so good at discriminating things like texture, shape, size. This is why your hands are so good at doing this. And the receptors are most dense at the fingertip. And so when you actually use your hand and your fingers to touch things, you tend to use a more sensory language, which makes sense because this is where you're kind of discriminating things like texture. And so is it hard or smooth or rough or even cold as well? And so emotional touch is still felt by the hands, but we think it's less here. And so these C-tactile afferents that I will talk about, they are very well known to be in the hairy skin. So they're very, very dense in the hairy skin, but we have also actually found them in the glabrous skin of the hands, some preliminary evidence that they are there. We don't know their role yet in the hand, but it's possible that they could contribute to, for example, the pleasantness of touch there as well. So we actually go into affective touch. What is affective touch then? Well, the hairy skin of the body is much more suited to affective touch because it's something that we receive. Affective touch is, we know it when we touch things, but it's really something like a nice hug will give you a positive emotion. And so the hairy skin does actually contain many C-tactile afferents, and these are thought to encode these positive affective sensations. And we've found that humans use a more emotional language for touch on hairy skin, such as a pleasantness or if it's arousing. And so it's of interest to understand the importance of this hairy skin tactile input for human social behavior and bonding. And so what we do is actually we can record from these C-tactile afferents as well as other afferents in humans. And I just want to present some of the work that we do. So we do this by a technique called microneography. And this is where we actually put a small electrode into a peripheral nerve of a human. What we have is, for example, the nerve will go in just by a small pressure and we put it in, and then we can stroke the skin of a human and we can record their actual responses from their touch receptors. So one single touch receptor. And you can see here at the bottom of the screen there, you can have the A-beta afferents, which I mentioned before, which give the discriminative aspects of touch. But then afterwards, you have kind of a slower signal, and this is actually the C-tactile afferents. And so this is a picture of microneography, and it doesn't hurt. It's actually quite enjoyable to see your own neurons being recorded from and hear them. And so we can actually stroke the skin, stimulate the skin, and record from these different afferents and see what happens when we touch them and when we stimulate them. So the C-tactile afferents, why are they special? Well, they are the only low threshold mechanoreceptor to exist in the C fiber range. And this range means that they actually conduct very slowly. So they take about 1 meter per second for the information to travel to the brain. So this is really delayed. So when you, for example, stroke your skin, the conscious information is almost instantaneous. However, the information from the C-tactiles comes in approximately a second later if it's from your arm. So this is a delayed signal. So why would it be delayed? Well, we think it's to give kind of an emotional aspect, a reinforcement to the initial touch. They respond to very, very light forces. They have small receptive fields, but they respond very, very well to slow, gentle, moving stimulus from about 1 to 10 centimeters per second. And this has been well studied in behavioral and psychophysical studies. So a gentle, soft stroke, not too slow and not too fast. This is what activates them the best. They also respond poorly to rapid events and vibration, which is why we don't think they are really involved in discriminative touch. So we think they are very much involved in the pleasant aspects, which I will go on to talk about. So in an amazing paper by Lena Loken et al. In the lab of Johan Westberg and working with many other great people in the realm of touch, they published the first evidence that CTs respond optimally to a slow, gentle stroking, and that this is actually correlated with the pleasantness of this touch. And so you can see here at the top, this is the CT firing to a 3 centimeters per second slow stroke over the skin. And what we find is anywhere between 1 to 10 centimeters per second is optimal. But then if you go too slowly, you can see it decreases here on the left of the curve. Or if you go too fast, it also decreases. This is the firing frequency of the CTs. So they can fire a lot, but the strength of the signal that they're giving is relatively low. And so this was then correlated with the pleasantness of the touch. And it was found to be highly correlated that when you deliver a very slow or a too fast stroke, it became unpleasant, but these intermediate velocities are perceived as pleasant. And this is what has really developed the social touch, the affective touch hypothesis. In 2014, in the same lab in Gothenburg, I published a paper with others, and this is with Helena Backlund-Bosling as well, I'd like to say, on that it's not just the speed of the touch, but it's also the temperature of the touch that matters. And this has further reinforced what we think of as the social touch, the affective touch hypothesis. And so you can see at the top here on the left, this is the average CT responses. And so in black, we have stroking at a neutral temperature, a skin temperature of around 32 degrees is higher than when you stroke at something which is cool at 18 degrees in blue, or too hot, which is 42 degrees Celsius in red. And so what we find is that over these same velocities, actually it modulates this curve, it goes up or down depending on the temperature. And so CTs seem to be very much in tune to a caress, which is slow, gentle, and delivered at skin temperature, which is why we think that CTs are so implicated in human-to-human skin contact. And you can see for an example that we recorded from hair afferents, for example, the hairs here, and their firing simply just increases with speed, and there is absolutely no change with temperature. We also correlated it with the pleasantness, and again, you can see that in black, the neutral skin temperature stimulus was very much the most pleasant, such as the CT responses. And so this has reinforced what we think is the role of the CT in social contact. CTs have also got a slightly complicated role though in temperature, because what we find is that for cold stimulus, they tend to, they fire quite a lot, but it tends to be at a lower frequency. So we don't necessarily think this is pleasant. This actually could be unpleasant. But what we do know is that for a hot stimulus, they definitely decrease their firing. CTs do not like hot stimuli, and it's very much the best stimulus for them is this neutral temperature stimulus. So coming back to the importance of touch, it's a language that we understand instinctively, like I said, but touch is a very complex language. And so it goes up from the kind of the top of this graph here, for the duration of touch, is it rough? What's the pressure? Are there edges? And it goes all the way through to temperature, to texture, to stickiness, pleasantness. Is it calming? Then all the way through to unpleasant side effects. So is it itchy? Is it painful? Is it unpleasant? Is it dirty even? Which is very important in this time of COVID. And so it's complex because we have so many different receptors which can encode this. And like I said, there are many mechanoreceptors in the skin, but there are also many other different afferents which send information to the brain about this touch. And so this is very complicated in that it's not simply the mechanical signals that deliver the touch. You have, like I said here, the A-beta mechanoreceptors, which deliver the conscious aspect of touch. You have the CT mechanoreceptors, which is more for the emotional, pleasant side of touch. However, you've also got nociceptors, which will be activated in touch. And these might be delivering more the unpleasant or the painful aspects of touch, or itch as well. But then you've also got the thermoreceptors, because these will not respond to the mechanical aspects of touch, but with touch, there always is a temperature element as well. And so you have to take on board the temperature aspect in touch, which is quite important. For example, if you shake someone's hand and it's too hot or too cold, you don't like it. And so this is another affective side of touch, is the temperature as well. So how have our habits and perceptions changed in the time of COVID? Because we know that they have changed a lot. So in the realm of discriminative touch, we have a very, very high awareness of our hands. And so you can see here from the pictures, you're told to touch things with a tissue, for example. You're told to open doors with your arms. You're told to use alcohol gel to sterilize your hands. There are also many no-touch devices that have been made, like special keys to push buttons to open doors. And so all these things are so restrictive in the way we touch, the way we interact with our world. They're helpful at the moment, but these things are barriers to touch, and we have to be aware of them and be aware of how touch has changed and how it can change in the future and what will happen in the future. So for the side of affective touch, though, this is potentially even more severe because our habits have changed extremely. So with social distancing, or maybe we should call it physical distancing, because we still want to be social, we just can't physically touch each other. We have lost this innate form of communication. We have lost this language that's non-verbal. It's something that's very important, but we now have this kind of loss of communication and the way we interact and the way we reinforce what we do in our lives. And I think this is especially has a big impact on children, because now we have to tell children, no, you can't touch each other. You can't play with your friends. We have to be aware that this could have a big impact in the future for them, which is not necessarily very good. And I really think we need to be careful here. And also that people might develop a fear of touch. And again, you need to stay clean, you wash your hands, things like this, but you shouldn't be scared to touch people. This is something which is very important, is what we're trying to show with the C-tactile work, is that we have a specialized system in our body which helps us communicate this affective touch. And so to become fearful of touch is really quite worrying. And I think as IASAT, as a community, we want to say to people that we want people to go out and touch each other when they can. Another aspect of touch that I found interesting very recently is touching your face. And so there's been a recent review article on this, which has shown that actually people touch their faces spontaneously many hundreds of times a day. And you do this especially when you're aroused or you're feeling emotional. And it's mainly negative emotions as well, kind of stress or shock, something like this, or when you have a cognitive load, when you're stressed and you might think like this. So when you actually touch yourself, though, your hands, which you've been touching all the other surfaces with, touch your face. And when you touch your face, especially with your nose and mouth, you can then infect yourself with pathogens. And so self-facial touch is a very important aspect of touch at the moment that we have to decrease. However, it takes a lot of mental effort to actually decrease touching your own face, because it's a natural mechanism to kind of relieve stress. You're like, oh yeah, it's just something that we do automatically. However, I think we all see this every day, that when people wear masks as well, the mask can slip or it feels uncomfortable, and actually people end up touching their face more. And this could actually increase the spread of the virus, which is also not good. And so I think this is something that we need to be aware of, how we touch our own face, our own self-touch. And so speaking of touching yourself, also about feeling dirty, is that a concept? We've kind of explored it a little, and there is actually a concept of clean feel. And so can you actually feel clean in touch? And so we actually did explore this, and I looked at how if people can feel cleanness through touch. And so we gave them 8 different textures to touch, or we had it passively applied on the skin to 20 participants at different body sites. And we actually found that when they rated the cleanness of the feel and also the pleasantness of the feel, these things were highly correlated, which is interesting in that when something feels clean, it feels pleasant. But what they also reported was when it felt clean, it also felt things like soft, and it felt cool. And so it seems that people have a perception of clean feel. You know when something feels dirty, and people reported that they can feel residue. And this is interesting as well in kind of investigating touch, the domain of touch, is that the mechanoreceptors, especially on your hands, are extremely sensitive. And it really is quite possible that we are feeling very, very small amounts of residue or dirt or stickiness with our hands. And this is to be explored, really, to what degree we can feel it. But it seems that people have already an inbuilt concept of clean feel, which I think would be interesting to investigate in the future. I just want to kind of end more with that if you don't have touch, it can have implications. And so recently I did a study with Ute Saylor, who's in Oslo. And what we did, we looked at people who had a lack of social touch. So we investigated individuals who seldom received interpersonal touch, and we compared these to controls who often received touch. And what we did, we stroked on their arm. It's using these same stroking velocities between going from slow to fast. And we looked at their pleasantness ratings. And what we actually found is that people who, this was before the pandemic, had less interpersonal touch in their lives, actually rated the pleasantness of touch differently. And so what we found is that people who received less interpersonal touch actually had a decreased appreciation of gentle touch. What happened, you can see in this graph, is that the line which is filled in, it's kind of flatter and lower than the general control group. And so what we think is that you need a continued exposure to interpersonal touch to really perceive that pleasantness, which again, it's very important in the pandemic then, that when we can touch each other and go out and be social, to do it, because then we really appreciate it as well. So in conclusion, I feel that you need both the discriminative and affective sides of touch. It's difficult to have one without the other. They always come together, or nearly always. And so the discriminative aspects are more the conscious aspects, the what, where, when. However, you have this affective component as well, which you think is signaled by the C-tactiles for the pleasantness, and maybe the C-nociceptors, the pain receptors for the unpleasant aspects as well. But this affective touch has got more of a modulatory and a reinforcing role. So was it gentle? Was it pleasant? Did I like it? And this is very important. And so the COVID pandemic has changed the way we touch and interact with each other, with our environment. There are many negative effects on touch. For example, feeling dirty, which is not good, and the distancing that we have. And hopefully one day we can get over this, because touch can strengthen human-to-human interactions. We need it for human bonding and to survive, to continue. And after this, we need to reestablish our social contact again. So I'd like to just end by saying we need to stay in touch. Thank you.
No, thank you, Rochelle, for that fantastic introduction to the topic, to some of the amazing work that you and others have done to lay the groundwork for what is clearly a global experiment for us all, figuring out what happens when these important little C fibers are getting a change in the amount of stimulation that they're used to getting. But I think what you clearly also put forward, and something that's certainly very, very much resonates with me, is the fact that we need to think about how these C fibers integrate with other signals.